Okay,
But it's example
410, writing quadratic functions and models. So this time they're going to give us, graphs, and we're gonna come up with an equation off of the graph they give us. Now, what are the three forms of equations we can have with quadratics? Intercept.
Vertex.
Okay, but
Standard.
let's, thank you.
Yes!
Okay, what is intercept form look like?
Line cosine equals speed.
Intercept?
Wait, no, that's slope. That's slope intercept. Y equals something plus x, parentheses, something plus x, parentheses.
Isn't that thought it was something that had to do with HK?
Intercept, is that what I asked? It does have HK in it.
I thought HK was vertical.
Is y equals a
Yeah, y equals a.
parentheses x minus h
Yep,
parentheses
squared,
Squared k.
how about squared
plus k.
plus k? Okay, that's intercept. Oh, that is
That's-
vertex, sorry, he gave me vertex.
Told you, let's go.
Okay, that's vertex. What's intercept? Intercept is what? Y equals what? A times what? What
And x
is,
plus b.
that's a line, that's not a quadratic function. Intercept equals what? Intercept equals what? If you don't know, you better start looking it up. I'm not telling you on the test or quiz, so,
I'll say a and then times something minus x1,
nope.
a times.
There are different letters in there. There's X's and there's different letters. Yeah,
Oh,
Say it.
P.
so it's X minus,
Oh, x minus p and then parentheses x minus q.
good. Now, what is standard form?
Y equals ax squared.
AX
bx
squared
plus c.
plus BX plus C. So when they give us a graph, we've got to determine what things do they give us so that we know what form we're putting it in. In this case, what things did they give us? A vertex and a point, okay? That's important. We need both of those to solve this. So we're going to then say, let's put it in vertex form. What do you think? Okay? So we're gonna come over here and we're gonna say the vertex of this one is 1, -2, yes? And the point they gave us was 3, 2. Okay? So 1, -2 should be obvious of where I plug it in. Where do I plug those numbers in? The what? It's the vertex. The h and k, yes. So it's x minus 1 squared plus -2, right? Okay. Now, if I have a point, where do you think I need to plug that in?
X.
The x and y. Okay, because I have to figure out what a is to get my equation. So I'm going to replace x and y. The x is 3, the y is 2. So I get 2 equals a. 3 minus 1 is 2, right? Squared minus 2. So 2 equals 4a minus 2. Add 2 to the side, you get 4 equals 4a, and a equals 1. So my equation should say y equals, if a is 1, I don't have to put it there, correct? X minus 1 squared minus 2. There's the equation of that parabola. Ask me questions. What's wrong, Elle?
So did you put the point in for x?
Yes, that's why you need a point. You have to have a vertex and a point, or you have to have 2 intercepts and a point, or you have to have, if it's this way, we'll talk about that. Because that's gonna take you some time. Okay, so if it's a vertex and a point, it's very simple. It's the easiest one for creating an equation. Because I plug the vertex in, I plug the point in, I solve for a, and then I write my equation. Okay, if a is 1, you don't have to show it. If a is anything else, there would be a number in front of that parentheses of x minus 1 squared, okay? Does that make sense how we got that? You're going to do a lot of algebra tonight, as in a lot of mental math and stuff like that. Easy math, okay? Personally, I like creating equations better than I like graphing them. Okay, because it's numbers. Okay. I'll give you a second, then we'll do this next one. Okay, let's say on this next one, it says, write a quadratic function for the parabola shown. What information do I have on this parabola shown?
Your x-intercepts.
And your points. Okay, so I have a point and I have my x-intercepts. My point is 3, 2 again, yes? And what are my x-intercepts?
Negative 1 to 4.
So -1, 0, and 4, 0, right? Those are my intercepts. So, intercept, intercept. So my equation has to be intercept form, which is y equals a x minus p times x minus q, okay? So I'm gonna plug in 3 and 2 for my x and my y. Anywhere there's an x, you plug 3 in, not just in one spot, in all spots, okay? So it's gonna say 2 equals a times 3. Now, my p is -1. So -1 plugged into a negative spot becomes +1. Okay, and then I have a 3 again, and then my q is -4, okay? So I do this, 2 equals a times 4 times -1, yes? So 2 equals -4a, which means a equals -1/2. Does my parabola face down? So does it make sense that that is -1/2? Okay, so then I come and I put my equation together. Y equals -1/2 times x plus 1, x minus 4. Those are gonna be your two easiest ones, vertex and intercept form. When we do standard form, we're gonna have some fun. So if you're doing intercept form, you need 2 intercepts and a point to plug in. If you're doing vertex form, you need a vertex and a point. Now here's the deal. What happens if they give you 2 intercepts but not a point? What would you do? Just find a point. Yes, find a point. Just find one. Doesn't matter what point you plug in, you're gonna get the same equation, okay? Same with vertex form. If they only give you a vertex, just find a point. That's easy. Pick something that's really simple and defined, okay? Because it's not that difficult. That's why they picked 3, 2, because it falls exactly there and that's easy. We could have picked 0, 3 as well, or 0, 2 as well, because it crosses through that y-intercept. Very easy, okay? Just pick a point. I want to pick what's curving up there though, because that's not falling through anything. I'd be a little difficult, you know what I'm saying? Okay. Now, this one's a little bit more difficult, okay? Difficult as in the sense of it's going to take you more time. Okay, remember how we did substitution and elimination with 3 variables? Kind of the same concept here, okay? Because it says write a quadratic function in standard form for the parabola that passes through the points -1, -3, 0, -4, and 2, 6. So we have 3 sets of points, correct? Okay, we have 3 sets of points, so we have to create 3 equations. Okay, and you have to use substitution for these equations, okay, eventually. So the form for standard form is y equals ax squared plus bx plus c, correct? Y equals ax squared plus bx plus c. I'm going to actually bring all 3 of these over. Okay. So you know that this is the equation we need to plug into right here, okay? Do you have a y and an x for all of these? Yes, we have 3 different equations. Okay, I'm gonna use the colors that are up there with those numbers. So -1, -3, I'm gonna put in green, okay? So that means I'm gonna take this equation and I'm gonna plug -3 into where y is, and I'm gonna plug -1 into where x is, okay? So I'm going to say -3 equals a times -1 squared plus b times -1 plus c. So you get this. -3 equals a minus b plus c. I have an equation. Do you see that? Okay, we're gonna leave that for a second. That's my equation right now. -3 equals a minus b plus c. And you see how I have 3 variables, like substitution and elimination? Okay, Now, I'm gonna come over to this equation that's in blue. My y in blue is, -4, yes? And my x in blue is 0. So you're gonna have a times 0 squared plus b times 0 plus c. Now, that reduces down to -4 equals c, yes? That helped us out a lot. That's gonna save us some time, FYI. So you see how I'm just plugging the x and y in and then just reducing it down to what I can get it to, okay? Sometimes you're gonna be left with an a, a b, and a c, sometimes an a and b, sometimes just one variable, it doesn't matter, it just depends, okay? Now, my final equation in red, my y is 6, and my, x is 2. A times 2 squared plus b times 2 plus c. So I get 6 equals 4a plus 2b plus c. I have 3 equations. Do you see that? Okay, 3 equations. Beautiful. Now, one of my equations tells me what c is, correct? Okay. My other equations have an a, a b, and a c in them, yes? Okay. So let us do a little work to figure some stuff out. Let us plug in the c to both equations. What do you say, to get rid of the c's? So that I just have a and b's left, okay? So if I plug c into this equation over here, I get this. I have -3 equals a minus b plus, and you get -4, yes? Because I'm plugging it in for c. Now, how do I get a and b by itself? What do I need to do with this -4? Add it to both sides. When I add it, you get 1 equals a minus b. Now I have an equation with just 2 variables in it. Okay, what am I gonna do with the red equation? Plug in c. 6 equals 4a plus 2b plus -4. Once again, what do I do with that -4? Add it to the other side. And you get an equation that says 10 equals 4a plus 2b. What do you think I need to do with those 2 equations?
Add them up.
Okay, kind of, Eddie. Add them up so that what happens?
So we can get the same A with the A.
Okay, we need one of them to be eliminated, so you have to do elimination. Now look, this b already has a negative in front of it, yes? So why don't I just multiply this equation by 2 so that the b's cancel? Okay, so if I multiply this by 2, I get 2 equals 2a minus 2b, yes? So I bring it over here and let's eliminate. I'm gonna add all these together. Okay, when I do that, 10 plus 2 is 12 equals 6a, divide by 6, and a equals 2. What do I do with that a? Plug it in. I'm gonna plug it in over here because this is easy. 1 equals 2 minus b. Okay, so I subtract 2, you get -1 equals -b, which means b equals 1. Okay? Now, I have an a, I have a b, and a c. Yes? And what is the form for an equation, standard form? Y equals ax squared plus bx plus c. So it's going to be y equals 2x squared, there's my a, plus bx, so plus x, plus or minus in this case, what my c is. There's your equation of that parabola. Y equals 2x squared plus x minus 4. Okay. And we're not doing the last thing that's in this, chapter or in this section because it has to have a graphing calculator, you won't be able to do it. These are the three things you're working on tonight. Vertex form, intercept form, and then standard form is gonna take you a little bit of time. Okay? That's what we're looking at.